Alrighty, so let's look at some parametric equations. And what that means is just that our x and our y variables have their own individual equations. And they're both based on the same parameter. Normally we use the letter t for this. And this is just an input variable where x and y are the dependent variables depending on the t. Okay. Sometimes, over on the right, the inequality, you're told specific values of t to use. Sometimes you're not. And then you pick appropriate values according to, the domain that might be there. Okay, so one of the things we want to do is graph it and figure out the x and y intercepts. So when you graph it, use the specific values. So I start at -2 and I just go up to 3. Now, depending on the equations, you might fill this in with a couple of extra values. Maybe you need to go 0, 1/3, 1/2, something like that to get a better visual of the graph. But sometimes you just do the whole numbers. If you have specific values of t, you never do anything outside of that interval. So I'm not going to do -5 or +10. I just start at -3 and I start at -2 and I end at +3. Take all of those t values, plug them into each equation for x and y. As you can see in my table, now you have the point xy that you plot the points. The other thing you need to consider is that because t has a specific direction, the graph needs these directional arrows to indicate that specific direction. So we started down here at the bottom, and then we proceeded to the next point along that arrow and curve around and go back, and it stops. There are no arrows at the end of these graphs because it starts and stops there. Alrighty, let's take a look at the intercepts. So if you didn't do the graph or the table of values and you need to figure out intercepts, for the x, the y is always equal to 0. And for the y-intercept, the x value is always equal to 0. So the x-intercept, you take the y equation, set it equal to 0, solve for t, plug that t into the x equation to get the x-intercept. Similar for the y-intercept, set the x equation equal to 0, solve for t, plug those t values into the y equation for the y-intercepts. And because these are equations and not necessarily functions, you can have multiple y-intercepts. Alrighty, the more significant thing, that is the primary homework questions, are eliminating the parameter and writing these as a rectangular, or Cartesian is the fancied up word. And I've got 2 steps. You pick x or y that's easy to solve for t, doesn't matter which, and you solve for t. Here the y equation, pretty easy to solve for t, and then you plug that into the other equation. And then you're done, like that. Pretty straightforward. So normally I keep cautioning in different places to avoid the plus or minus square root in solving for something and then using it to do something else. And that's the same situation here. I wouldn't want to t equals plus or minus, etc. like that. You could, but it's easier to go the easy route. This last example, a little more complicated. There is one homework question on WebAssign and probably in the lab manual, not on the test. Pardon me. So again, pick one of the 2 that's easier, and it doesn't make any difference. I think that the less complicated exponent, so the y equation, is easier, but anyways. So we need to isolate the exponential part, so we're going to take the coefficient 2 and divide it. And the technique from algebra that you may or may not remember is we apply the natural log. Now this is a function that we're applying. We're not multiplying by ln. The result of that is on the right side. The natural log function and the exponential function are inverses. And in this case, they cancel each other out. And you can see the -t is all that's left over. And then you take that negative, put it on the left, so now we have t equals. That's step one, solve for t. The second step is to plug it into the other equation, and this one has some more simplification that we want to go through. So there's a -2 and a -ln. The negatives cancel. One of our logarithmic rules from algebra is the coefficient of the natural log becomes an exponent on the inside. And a similar property, we've got the exponential base and the natural log and the exponent cancel each other out. And so that exponent then is our answer, and we went ahead and squared it. And there is the answer. So that is all of algebraic parametric equations. We'll look at trigonometric ones next time around.